About 5% of the entire Gulf of Mexico, if you look at kind of the daily logs on GeoPlatform from NOAA, about 5% of the total Gulf was impacted by the oil. Maybe 10% of the northern Gulf if we're looking at U.S. waters. And so these species we're talking about live all over the place. And so they'll reproduce in these other places that weren't impacted and fill in the gap once the perturbation is gone. And so only time will let us know whether or not that's the case. We may have a little bit of a down year this year, but then back up next year. The oysters produce huge, huge quantities of eggs. They're all over the waters. The controlling factor there is a substrate to land on. Most of the northern Gulf is soft sediment. Yet the oyster reefs are hugely productive, primarily in Louisiana, although they're in all the states. So it's a mixed bag.
Ed, did you want to add something to that? And then I'll ask Pete.
Yeah, we know that the oil was heavily weathered. It was dispersed at depth. A lot of it stayed down there. A lot of it that came up to the surface in tiny droplets, which basically was extracted by the water column. So in the Exxon Valdez, the release was at the surface. There was a black tide, and a black tide came ashore on a rocky shoreline with large tidal fluxes. So fresh oil onshore buried in the intertidal areas in there. That doesn't appear to happen significantly in this spill, thank God. Weathered oil got to the surface. It meandered around because there were no strong weather fronts and ocean currents that would bring it in. So by the time patches of shoreline were oiled, little eddies broke off, but it was a mousse. It was heavily weathered, and the lighter, more water-soluble components had weathered off. Now, this means that you don't have a lot of the components that can dissolve down in the water column and have as big an impact as you would have from fresh oil. Now, I hope I'm not being optimistic. I'm a citizen of the Gulf, and I certainly want the Gulf to come back. So I will add that bias that I'm pulling for the Gulf, but we need to be careful. But weathered oil came ashore. Weathered oil was mostly on the surface, and weathered oil is significantly less toxic and dangerous than heavy. It has a smothering effect. It has an oxygen depletion effect, but a lot of the toxic effect due to the solubility of these compounds and the fact that it was offshore hot water was lost by the time the marshes were impacted. So knock on wood, I'm optimistic that some of the impacts are not going to be as dramatic as we're seeing, for instance, in Alaska, where there's still impacts 20 years later.
Yeah, Pete, would you like to tell us about that? And do you share the optimism of the gentleman to your left?
No.
What did I tell you?
No, I just wanted to add a couple things. First, just relative to the fate of the oil, we dodged a huge bullet in this. I hope people recognize. If you look at this time of the year, you're usually getting very good onshore winds, bringing that in. It's gotten to that season where we should have had transport of that oil relatively rapidly to the Gulf shorelines. In addition, the oil should have been caught up into the loop current and sent on over to West Florida and the Florida Keys in some form. We dodged both of those bullets in this spill, so that's just one of the, I think we all know that, but I wanted to add to that. Then I wanted to add a bit to the fisheries story that Wes was saying. Shrimp are the weeds of the system. So shrimp are out there, you know, a couple-year lifespan, and so they can respond quickly and return readily. But we do have a group of fishes that has very long lifetimes and are a consistent management problem and are plaguing marine fisheries and state fisheries as well. The hard-bottom reef fishes, the snapper grouper complex, we like to call it. And those fishes are ones that will not come back readily if they were impacted. Now, I don't know if they were impacted or not, but I wanted to raise that the life history differences among organisms will lead to great differences in their responses over the long term. And then finally, the fate of the oil. There's one additional part of this that does relate some to the Exxon Valdez and to issues that we discovered there about persistence of even weathered oil and the consequences that that can have over a very long period of time. And that is that there is oil deposited on the soft sediment seafloor over some substantial area. How far and what the area is not known. It's millimeters to centimeters of a black deposit, high in total petroleum hydrocarbons, high in total PAHs. In addition, there's a section down slope of the well that has an asphaltene cover, which won't degrade very readily, if at all. But it's this cover over the soft sediment bottom, and some of that cover has also extended to the deep water corals and some of the hard surface bottom in the system. So that is going to represent a much more long-lasting consequence to the system. And in particular, in the soft sediments, what we've learned through recent work of Bufadl and colleagues in Alaska about some of the persistent oil and persistent toxicity is that oil that is sequestered away from oxygen and away from nutrients, which mostly means nitrate, will be very slow to weather and will stay persistent. So if that's a system also where physical or biological activity re-exposes key organisms, it can then have the effect, as it had in Alaska, of a decade and longer of exposure of things like sea ducks in Alaska, sea otters, and in our system in the Gulf, deep sea things that we hardly even know about, where the Census of Sea Life and Ron O'Dore had better tell us great things about. So that's the part of the oil that I think, to me, continues to be a great concern. There also is concern in the marshes and the soft sediments near shore, where that kind of thing can happen too, and where oil can be buried. And I mean, after oil, these great reservoirs of oil are not being degraded by bacteria and are out of touch with oxygen and nutrients as well. Of course, it's a little bit different to talk about something that's many kilometers deep and enclosed
under the mud line, yeah,
enclosed in salt and basalt and other things.
So, well, Dave, if you could, I mean, I think one of the sort of overarching questions is do we have really enough information to appreciate the impacts, both biological? We're starting to hear some of the data gaps, the big question mark still in understanding that. But what about the economy of this? I know that like NSF had prompt grants that went out. A lot of people went out and started doing research right away on some of the biological and chemical systems. What about the economics of that? Was that responded to in a similar way?
Well, I think looking into the future, there's uncertainty, obviously. And much of it's going to depend upon what happens in the biological, physical systems. What we don't have a lot of information on is, once again, getting back to this natural economy, these services, ecosystem services that we're talking about, and how much we rely on these. I mean, we may not know that that marsh and that oyster reef out there are doing those things that are impacting our well-being, but once they're gone, then we feel the effects. And we don't have a lot of information there, and that's where we need to be putting resources into the future. But there is, I mean, the agencies are stepping up to that. EPA, NOAA, USGS, they're all stepping up and saying, okay, yeah, ecosystem services, assessing those, valuing those is really important. Not just for this event, but just in general, if we're going to make better decision-making with regards to our natural resources.
Yeah, and at Overton, I'm sure that's something you've been looking at over the years, because it's not just the oil spill that affects those marshes, but clearly the history of the oil and gas industry in Louisiana has been cutting channels and degrading a lot of those wetlands to begin with. So, I mean, how do you compare what you've seen over the last several decades to what's happening now in a much more, maybe in a more prompt and certainly more dramatic fashion, but
Well, the Delta is clearly a very, very sick part of our environment. It's the one thing that would strike me every time I fly over is just there's not much left. It's just amazing. You look down, you see where canals were drilled, and you can see the spoil bank, but there's nothing around them. It's open water. All of that used to be coastal marsh. So that's the real story. I mean, the oil spill is a hiccup on the side of a massive loss of a national treasure, our coastal wetlands, which protects it, which serves as the breeding ground for all the organisms that we've talked about today. That to me was the real story, to be just blown away at how much we have lost. If you look at a map of South Louisiana, you're not looking at hard land. That is a figment of somebody's imagination 20 or 30 years ago. Doesn't look anything like that now. Look at any satellite photo and you'll see there's a little sliver of land that follows the Mississippi River. The rest of it's open water. 30, 40 years ago, it was all marshland. So
Yeah.
big problem.
Yeah, the Oil Spill Commission did, one of its recommendations is to take the Clean Water Act fines that BP will ultimately pay, perhaps, and invest that essentially, most of that, 80%, if I recall the number, in essentially trying to restore the delta, thinking about some of the nutrient overloading issues as well, things that are not related to the oil spill, but are sort of the long-term consequences, I guess, not only of the oil and gas industry down there, but of all the nutrient overloading that comes down from the Midwest, from the breadbasket, the place that grows the food that we eat. Does that, I'm presuming you think that sounds like a sensible idea?
You better believe we think it right. I see Dr. Turner down here, who's, and Nancy Rabelais, who are big proponents. They know a lot more about this than I do, but everyone along the Gulf Coast expects that most of that money will go to some sort of reasonable restoration plan, but not, it's for the Delta. If we don't restore the Delta, we won't be talking about the fisheries in 20 to 30 years we're talking about now. We won't be talking about the infrastructure that supports oil and gas. If we don't support the oil and gas, we won't be talking about driving and flying to Washington, D.C. for this conference. There's a lot of things we won't do if we don't protect that environment.
And Pete, you wanted to add a word, and then I'll go to some, we have tons of questions from the audience.
I did. We're talking about the bigger picture issues of multiple stressors in the system. I want to refer people to a product of the U.S. Global Change Program that was orchestrated, funded by Congress, orchestrated through EPA, called the SAP, S-A-P documents. And SAP 4.1 was written by Rob Teeler and a group of coastal geomorphologists and geologists. What it does is give the results of a bathtub model of where the waters will be and where the land will be in certain times into the future on the basis of assumptions, realistic assumptions of sea level rise. That model shows that the problems that we've seen in the Gulf and in the marshes of the Delta are just the tip of the iceberg of what's coming. And what that means is that one has to be very careful in designing restorations for this spill so that the restoration is sustainable and so that what you do has resilience. And that applies to the human systems as well. So we have a huge task ahead, and that is to create a sustainable ecosystem that is resilient and continues to affect the socioeconomics of humans that live there indefinitely in the face of major perturbations, and those include sea level. And I should add, this SAP 4.1 modeling, so-called bathtub modeling of sea level rise, is a gross underestimate because it fails to include erosion. And if any place is eroding with storms, I can pick one, and that is this one.
And subsidence too, for sure. Let me go to some questions here. And here's the first one. It says, the EPA has provided the composition of Corexit 9500 used to chemically disperse at depth and at the surface. You keep mentioning that the dispersant is toxic, yet all of the components of Corexit are used in food, baby soaps, laxatives, et cetera. Can you comment on why it is called toxic? Ed, you want to take that?
Well, dispersants have a long history, a long sordid history. Initial dispersants were very toxic, caused more damage than the oil back in the Torrey Canyon days. But the modern dispersants are much better and less environmentally damaging. By the way, NALCO provided me and anybody that asked, as far as I know, the composition of the dispersant. So this wasn't a secret. I asked and was immediately given, this is what's in it. They didn't tell me the composition. That was the proprietary. But the chemicals that were in it. And basically they were all licensed by FDA for use in foods or around foods. In most of the common foods that we eat every day, some of those chemicals that were in that dispersant. So that doesn't mean I would eat the dispersant.
Right.
By any stretch of the matter. It was a soap. It was a strong soap. Didn't taste good. Doesn't taste good. But the real damage from dispersants is in the dispersed oil. You're taking oil that's thick on the surface, spreading it out and over a larger area, and those components are now available, so you have a route of exposure to the organisms that are floating around there. By dispersing it, you also make it more bioavailable.